Hey there, in this video I'll be showing you how to build multi-file C++ programs. And let's start by thinking about why you want to do this. Professional programs can be very large, probably thousands or maybe even millions of lines long. We're going to want to split them up into multiple files for many reasons. Like 1, it makes them easier to store and search. 2, you can compile only what's been changed, and that saves a lot of time. 3, different programmers on a team can check out and work on different files in parallel. So a bunch of reasons like that. Now, any IDE that handles this is going to have a facility that's usually called a project to track all of the files and connect them together. In this video, I'm going to be doing this in Dev-C version 6 on Windows. Now, if you use a different IDE, like maybe xCode or Visual Studio, you're going to have to look up the analogous feature on your own, but they basically all use the same idea. We're going to be doing this in 2 parts. In part 1, I'm going to show you how to build an existing program where someone has supplied all the source code files for you. And then in part 2, we'll make a brand new project from scratch. So let's get started. So in this part, we'll be building an existing program where someone has supplied you with all the source code files in advance. And the example we'll be using comes from the Tony Gaddis textbook, Starting Out with C++ from Control Structures Through Objects. We're going to chapter 13, which is where we begin object-oriented programming for the first time with multi-file projects. And we'll be using the very first example in that chapter, which is titled Rectangle version 1. It has a class to make rectangles. So I have this folder, Rectangle version 1, open on my desktop right now. And you can see that this project has 3 files in it. You've got rectangle.h, which is your header file defining this rectangle class. You've got rectangle.cpp, which is the implementation file, and that has all the code to the functions in that class. And you also have the application file, which is titled pr13.5, and that's the file that actually has the main function in it. So I'm going to open up Dev-C right now. And the first thing I'll point out is that Dev-C has this sidebar on the left that we probably haven't used too much so far. And among the 3 tabs, the very first tab is labeled the project tab. So here, as we make our project and we add files to it, it's going to list all the files there. And it'll be very convenient to keep track visually of what's in our project. So we'll keep an eye on that as we go forward. Very first thing I want to do is make a project. So I'm going to click on File, and then New, and then Project. And what we're doing here is we're making a console application. All of the examples in this particular textbook are console applications that you could run on the command line. We're making a C++ project. I'll give it a good name. I'm going to title this Rectangle Test. Our main goal here is to make a rectangle object and test that its functions work. So Rectangle Test is a pretty good name for this. I want to save this in this folder. All of the new files that we make, we want to keep in this one folder to keep them organized and easy to find each other actually. So here on the desktop, I'll find this folder Rectangle version 1, and I'm going to save this in here. And you can see that we've made a new file. It's called rectangletest.dev. Windows is showing it as a Dev-C project file. Some of us might also refer to this as a development file. You can see that in the project tab, it's listing this new project, Rectangle Test. And if I click on the little arrow next to it, we're going to list all of the files currently in the project. Okay, so by default, Dev-C makes a main.cpp file anytime you make a new project. We don't actually need that because we have all the files already. So I'm going to remove that. Over here in the project tab, I'm going to right-click on this main.cpp that it made for us and get a little menu here. I'm going to click on Remove File. Right, and it's asking us to save changes to this main.cpp that it gave us to start with. I don't actually need that. I'll just click No. Now, at this point, so now there's no files in the project. We'll add them in just a second. At this point, you notice that another new file popped up, and that's called rectangletest.layout, a layout file. That's not actually part of the project. That's actually just Dev-C keeping track of what we're currently looking at. So that if you close it and then reopen Dev-C++, it shows you the same files you were working on before. You can delete that if you want. It's not totally necessary. But what I need to do now is I need to add the existing files to this project. So what I could do is I could click on Project, Add to Project, and click them through there is one option. Another alternative is over in the Project tab, and this is what I personally normally do. You can right-click on the project, and you basically get the same menu here. I'm going to click on Add to Project. And again, looking in this rectangle version 1 folder, I'll pick the C++ files that I need. So I'll add the header file, I'll add the implementation file, and I'll also add the application file. So those 3 files that make up the project. Okay, so now those files are here listed in the project tab. Now, the development file, rectangle.test.dev, that doesn't actually have any source code in it. It's basically just an index of what files we've added to it so far to keep track of. It's like a table of contents, right? These are the only 3 files that actually have C++ code in them. I'll even say that rectangle.h, adding that to the project is optional. The only thing that's actually going to get compiled are the CPP files. So this would work if I just added the CPP files to the project. The pound includes is how the compiler would actually find all the header files. But I do find it convenient to add all the header files to my project as well, because now if I want to look at them, I can just click on them in the project tab and it will load them and show them to me. So here's rectangle.h, and there's your header file. Got the include guards there, right? Here's the definition to the rectangle class. Here's rectangle.cpp that actually has the code to all the functions there. And here's pr13.5, which is the file, the application file that actually has the main function there. Makes a rectangle, starts calling some functions on it. So there's everything that I need. At this point, I ought to be able to compile it. So I'm going to click on Compile, the Compile button in Dev-C++. And we'll also keep an eye over in our project folder and see what new files pop up as a result of the compile. Okay, so we just got a number of new files there. First of all, there's makefile.win, which has the parameters of everything that's being built sent to the maker. The compiler here has taken the CPP files and then done the compile job, generated machine code, and it stored them as these .o object files. So rectangle.cpp got compiled into rectangle.o, is the machine code version. pr13.5.cpp got compiled into pr13.5.o, which is the object file. And then finally, the linker ran and took those .o files and combined them together and put them into rectangle.test.exe. If we look at the compile log down here, we can see specifically all of that stuff happening. So let's just take a look at that. So here's the project file name, rectangle.test.dev. And the very first thing is that it made this makefile.win, which has all the parameters of how it's going to be built. And then it's calling these command line programs like this maker, this make application, and sent it our makefile.win, our makefile. And then that maker independently called our compiler, which is actually the G++ compiler program. There's the command calling the compiler and saying, hey, take pr13.5.cpp and turn that into pr13.5.o. And then called the compiler again and sent it rectangle.cpp and said, you better generate a rectangle.o out of that. And then finally called it again and sent it the 2 object files and said, put those together and make a rectangle.test.exe out of that. So that's actually all the separate calls to our compiler that's happening as a result. And the compilation results is that it did successfully make rectangle.test.exe, and there's no errors, there's no warnings. Everything looks good at this point. So now that we understand that, we ought to be able to actually run the program and see whether it works or not. So I'm going to click on the Run button. And here's my console. It's saying this program will calculate the area of a rectangle. What is the width? I'll make something up. Maybe the width is 3. What is the length? Maybe the length is 5. And all this information is getting stored in our rectangle object in the main function. And you can see that it is successfully storing the width of 3 and the length of 5. And the object is also automatically calculating the area of 15. And that all looks correct to me. Now, when we ran that, we got yet another new file in our folder. And you can see that here, gmon.out. So the compiler we're using comes from the GNU organization, and for what it's worth, this file here is the GNU monitor. And that actually has a bunch of statistics about how well our different functions ran, specifically how much time was taken up by each of the function calls. And there's another program called the Profiler that you could load this data file, this gmon.out data file into it, and see reports of exactly how efficient all your different functions are. If you don't want to see that, you can go into the compiler settings here in Dev-C++ and turn that off and not see that anymore, but I usually just leave that on like that. So there we have successfully built this multi-file program. You can see there's a bunch of files that are going to get generated now as a result of that. I think we're pretty good. I'm going to close this down. It's going to ask me to save changes in the project, in the development file. I think that's a good idea. So I'll click yes to that. And we've now successfully built our first multi-file C++ program. Now, in this part, we'll be making a brand new C++ project from scratch. And the example I'm going to be using is in the Gaddis C++ book, chapter 13. The very first programming challenge is called date. And the goal here is to make a class to store date, including the day and the month and the year, and a couple different functions to print the overall date out in a variety of different formats. We'll just get started with this. So as always, the very first thing you want to do is to make a folder to store all the various files that go in your project. I've done that here. I have a folder called date on my desktop. The folder is currently empty. We're going to be making all the files that go into this using Dev-C++. Let me just make this as small as possible for visibility purposes. And I'm going to start up Dev-C++. And of course, I'm going to begin by making the project file. So again, that's File, New, Project here. Right? A console application, a C++ project. Give it a good name. I'm calling this date test. Now, for all these files that you're making, you want to be really careful to keep track of the location. Make sure that you save every single file in the same project folder altogether is the easiest thing you can possibly do. So for me, this is on my desktop in this folder called date. And at this point, we have the beginning of our project file. There's datetest.dev. You can see that in the project tab of Dev-C++, here's our date test project. And if I open that up again, Dev-C++ always gives you this starter main.cpp file anytime you make a new project. Now in this case, we're actually going to use this as our application file. So anytime you make a new file, the very first thing you ought to do is add the comment header. If you get up, you go away, and a member of your team comes over, they ought to be able to see who made it and what the goal is. So I'll do that right now. We don't need this comment here. This isn't doing any good for us. I'll remove that. But I will add the Dev-C++ style comment header, and we can get that if we click on Edit, Insert Snippet, Comment Header, as always. Going to fill this out. The name of the project is date test. Right, the copyright, I'll just add the current year here. The author in this case is me, Daniel R. Collins. It automatically added the current date and the time that we're making this. And my short description here is going to be test the date class. That's the point of this main file. Okay, so good enough to begin with. I'm going to save this. Remember, put it in that same folder. Be very careful about that. We could give this a name like possibly datetest.cpp, right? Again, it's starting us off with main.cpp. I want to refer to what the program is. I don't want to add my name. I don't want to add project number 5 or something like that. You know, the point of this file is to hold the main function. So main.cpp is good enough. You know, maybe something else, but this is good enough for now. I'll save this. And now we've got main.cpp in our folder. Great. There's our first source file. What to do next? Now, obviously, I need the class. I mean, that is the whole point of this. So let's make the date class. Any IDE, including Dev-C++, ought to have some kind of facility to rather quickly make a new class and the number of different files that you need to manage it. So I'm going to use that right here. In Dev-C++, that's going to be file and then new, file new. And you can see in this submenu, the very last thing there is class. Make a new class. We'll do that. So File, New Class. And you get this wizard here with a bunch of different options for how you want to structure your new class. Now, obviously, in this case, the name of my class is date. Okay. I could have it automatically create a constructor for this class if I wanted to. I could have it automatically create a destructor if I wanted. If I was having it make the constructor, then I would specify what arguments I need to come into the constructor in this field. For this example, I'm going to skip that. We could also have it inherit members from another class. That's somewhat more advanced behavior. Gaddis doesn't get to that in chapter 15, so I'm also going to skip that here. I'm not going to inherit. I don't need to use the inheritance section. If I look down here, I can see the names of the files that it expects to make. The source file name, it expects to make date.cpp, okay. And the header file name, it expects to make date.h. Now, you could change those file names if you wanted to, but those are the customary titles for files dealing with a class called date. So again, I don't want to surprise my team members with different fancy names. I'll just use the traditional names called date, which makes sense. And then by default, it's going to add both of these files to my current project, which is totally what I want. So I think that's all I need here for my date class, and I'll hit create. And you can see that it's added date.h and date.cpp. It's given me some starter files to work with. We're currently looking at date.h, and it's given me the include guard that you need, and it's also given me the beginning of a class definition here. It doesn't have any members yet. Let's think about what's in there. So it's given us access specifier labels for public and protected. Now remember, in C++, there are 3 access specifiers. There's public, there's protected, and there's private. Protected is something you only use in conjunction with inheritance, and we're not doing that here, so I actually don't need that section. Why did it leave out private? Well, in C++, if you add a member and you don't put it under an access specifier label, then by default it's automatically private. That's the safest, most secure thing that can possibly happen. So I can kind of see why they thought they could get away without that. But in our code, we don't want things to be a mystery. We want to be very explicit to our fellow programmers. So I will add a private label so everybody can immediately see what things count as private. I'm going to remove this protected label. Not using that here for not doing inheritance, but I will add an explicit private label. Okay, so what kind of private data should we add? Remember, this overall project is supposed to have a day and a month in the year, but I'm just going to start with 1, right? You want to write a small amount of code and just test whether that's working. So I'll add a member to hold the year. Obviously, the year is an integer, and your data should go in the private section as always. So an integer called year in the private section. What functions will we customarily have to work with a member like that? Well, you want an accessor to report on it, and you want a mutator to set it when you need to. Those kinds of functions go up in the public section. These function prototypes here. So my accessor, it just returns the current value of year, so it has to return an integer. We would normally call this getYear. And an accessor like this doesn't take any arguments, right? You don't have to give it any information. It's just returning information back about what the year is. On the other hand, we want a mutator to change the year, to set the year. So a mutator like that is going to be a void function, doesn't return anything. We're telling it what to store for data. We would normally call this setYear, right? And this does have to take an argument, namely an integer for the new year. Okay, so I think that's what I need. 1 piece of member data, and then an accessor and a mutator to go along with it. So I'm going to save this header file, again, in that same folder. And now we've got the date.h header file saved. Great. And now I can actually start adding code to those functions over in the implementation file. That's date.cpp. So I'll flip over here. And you can see that when Dev-C++ gave me this file to begin with, it automatically added the include statement. Obviously, if you're going to be dealing with date objects, you need to include the definitions, which are over in date.h, of course. So that's kind of handy. Now I'm going to start adding the code to those functions. And the first one there was the accessor. So here's the year accessor. That's a function that returns an integer. And remember here, the full name of the function includes the name of the class. So the full name here is going to be date, right? Scope resolution symbol, and the name of the function here is getYear. Right? Doesn't take any arguments. That kind of function, very short, right? All it's going to do is it's going to look up the year variable and just return that number. Remember, the year here that I'm referring to, that's the member variable. Define that over here in date.h. That's what we're talking about right here. So just accessing that number and returning it. Now, we also have the year mutator, of course. So I've got to add code for that. And that's a function that's a void function. Again, the full name is date, : : and of course, Dev-C++ is scanning date.h. So it knows my definitions at this point, and it's giving me this pop-up menu of here's the options. There's only two things in the date class. There's the getYear function, and there's the setYear function. So I can just pick it out of this menu to save a little bit of time. I could type setYear, but I'll just pick it here. So obviously there's the setYear function, and this little pop-up here is reminding us that this function takes one argument, namely an integer. Now, in the prototype, I only had to give it the type of the argument, which is int. But here in the function header, I also have to give it a name. So in this case, I'm going to name this y. Okay? We could possibly come up with a better name for that, but I definitely don't want to call it year because that would cause a name collision with the class member that's called year, so I can't do that. I'll just call it y, good enough. And again, this kind of mutator function, very, very short and simple. You just take that incoming number that we're calling y and assign it into the year class member. So year gets set to what this incoming y is. Great. That's all you need there. So I've made one member variable, and I've written the minimal, the smallest amount of code I can possibly get away with to do something with it. And at this point, I want to test whether those functions actually work or not before I start adding more complicated code. So I'm going to save this file right in that same folder. So now I've got date.cpp saved there. Great. And now to test that, that's what the main test driver is for. So I'm going to flip over to main.cpp and start filling this out. And to begin with, obviously, again, you need to include the definitions. So I'll include date.h, so the compiler will read the definitions as it scans this file. We're also in the habit of making use of the using namespace command. So getting access to the standard library by default, things like sin and count and endline, without doing too much typing for that. And I'll give a lead-in comment to this. This is my main test driver function. All right. So to test the date class, what do I need? Now, obviously, I need to make a date object. I need to instantiate one of those things. So making a variable, the type is date, capital D, and I also have to give this variable a name. You know, one thing you can do in a case like this is you can name the variable the same as the type, except obviously I'm going to use lowercase d. Right? If you're just making one object, this can make sense. Any programmer will immediately see on sight that capital D date, that's the type, lowercase d date, that's one of those objects. So that's pretty obvious and understandable for most people. Now, I need to save some data in the object. That's what the mutator is for. So to call the mutator, remember all these object-oriented functions are going to be object.function. So name the object, which is date, and then dot. And again, you get a little pop-up here. Just a couple things here in this class right now, and the one that I want to call is the setYear function. Okay, and for the one argument that you need, I'm just going to pass in the current year, which is 2024. All right, so call a mutator, save some data into the object. Now we got to test whether that worked. I'll call the accessor to get a report on what it currently is. So this will be a printing statement. I'll print out a good label to be really clear when someone reads the program what's happening. And this is trying to print out the current year, right? And to get that information back, I'm going to call the accessor with date.getYear. Great. Put an end line there to make the formatting nice. So I think that's a good start. And that's customarily what we do when we're adding members to a class. You instantiate an object, you call one single member to change some data, you call one single accessor to check the state of what the object is like currently. And that's a pretty good test to begin with. Now I'm going to try to compile this. I think we have everything that we need. Once I save this, save any changes. So I'll compile this and we'll keep an eye over in our project folder. Hopefully if this works, we're going to see a whole bunch of files show up as usual. You compile. I think that worked. And you can see again, it made the make file with all the parameters of what's getting compiled. It compiled the two CPP files into object.o files. That's the machine code. So date.cpp got turned into date.o. And main.cpp got compiled into main.o. And then finally, those things got linked together. And now we have datetest.exe, and that's our application. Cool. So obviously at this point, I had to run it, see whether it actually works properly. I'll hit the run button. Bring the console over here. And you can see that looks like that's correct. It's printing out current year 2024. So I would call that a successful test. It looks like we did create one of these objects. We successfully saved some data in it with the mutator, and we successfully got that data back with the accessor. So I would call that a successful test. Great. And we're on our way. Now remember, if you're going to complete this programming challenge out of the book, you'd come back here and you'd start adding more members to the class. You'd also have to add a member for the month with its accessor and mutator. You'd have to add a member for the day with its accessor and mutator. And you'd have to add the several different functions to print the overall data out in a variety of different formats. But I'll let you do that. The important thing is that we can get started making the several files to manage a project like that. Just get a little bit of code in there, right? Test it as soon as you can. Add one little thing, add the minimal amount of code you can possibly get away with, and just try to test one or two functions at a time before things get too complicated. And that's our overall process to building a larger class. So I think this is pretty good. I'm going to close this. I'm going to save my project. So hopefully that gives you a good foundation for making larger programs in C++. You're using object-oriented programming at this point. You're splitting your larger programs up into multiple files. And hopefully that gives you a good basis for larger projects and more sophisticated projects going forward. I hope that helps you going forward, and I'll see you next time.